Okay, question number 3. We have this product function where we've got this 5 minus x bracket e to the x on 2 plus 1. Okay, so question part A says find the derivative. So it's a 1-mark question for typing the derivative. So interactive calculation diff 1, and I'm just going to write that on and say f dash of x equals, not going to change anything, just going to write it exactly as it is, x e to the x on 2 minus 3 e to the x on 2. Other forms would be possible. Now, always be mindful, why have they given you 1 mark for writing the derivative down when all you did was put it on the calculator to calculate it? And that's because they want you to use it. Okay. So, part B, find the values of x for which the gradient function is strictly decreasing. Okay, so it's about the gradient function strictly decreasing, not this graph, because this graph is f. So if I look at the gradient function, open up the graphing window, edit, they're all okay. I can see that this graph was the increasing function for all the way along here, but then not down here. So if I do analysis G solve max, that's at x equals 1. So the gradient function is strictly decreasing from minus infinity to 1, inclusive of the 1, because strictly increasing we have square brackets. So this question was about the gradient function, not the actual function. Part C, let g of x equal f of x, where it has the same rule except it's got a restricted domain. So this is now about this function, f of x. Find the value of a so that g has a maximal domain given that it has to be, so it has to be 1 to 1. And for it to be 1 to 1, then we've got to stop it there, which means 3 has to be the maximum domain because I'm going to get rid of all of that so that my function is the 1-to-1 function. So a equals 3. And what is the domain of g? Well, the domain of the inverse will equal the range of g. And if I look at my graph, my range of g, my highest point will be here, and my lowest point, well, it's asymptotic, because I've got an asymptote there at y equals 1. That point there will be when x equals 3. So 2e to the 3 on 2 plus 1. So my domain will be 1 not inclusive up to 2e to the 3 on 2 plus 1 inclusive, because the domain of the inverse will be the range of the original, and the range of the original is this curve here with the restricted domain of going up to 3. And the trick at the bottom end was it's asymptotic to y equals 1. So that's A, B, and C.